All right, folks, it's Mr. Koontz back here again. We are going to be doing section 2.5 today, the first part of it, because I only can do part of it. It's going to take a little bit of time to do both pieces we're going to do. In 2.5, we do determinants and multiplicative inverses of matrices. Today, we're just going to handle the determinant side of it. So I'm going to go over to my notebook, and we are going to start talking about the determinant of a matrix. Now, the first thing is just a little bit of talking. One of the things, a determinant is a number associated with a matrix. Now, what does that mean? We're going to get into how to use it in the second half of this. Right now, we're just going to try to find what that number is. So I want you to put kind of in the back of your mind, be at ease with the fact that you don't really know how to use the determinant right now. We're just trying to find out how to find the determinant. And it is, again, a number associated with a matrix. Now, it's only a matrix. We can find determinants for matrices of nth order, meaning only for square matrices. All right. And I'll write it as I said it, only for nth order matrices. And if you remember when I talked about the intro to matrices, when we talk about a first order or a second order matrix, that means a 1 by 1 or a 2 by 2 or a 3 by 3 matrix. So only for those matrices is what we're going to deal with. And we're going to start with the idea of value, and it is a number. When we talk about the determinant, it is a number. And so we're dealing with a number associated with a matrix. And if we look at, I'm just going to start with a second order, just as the basic idea. For a second order matrix, we have this as our general idea. If we said A11, A12, A21, and A22, that would be our second order matrix. Now notice I did something different here. I didn't make the brackets on the end of this matrix. This denotes the determinant. All right, what it's asking you a question. All right, it's saying what is the determinant of this matrix. So if you ever see this, and this happens every year, we get to a quiz and it'll say number 3, and next to number 3 is just this picture of a matrix with these brackets on the end, or you like the absolute value look. All right, and people will ask, well, what do we do for this one? And I say what it's asking you to do, because this is asking you to find a determinant. All right, it doesn't need to say anything else. Okay, you have to recognize that there's a difference between this and when we put the feet and the top on the brackets. All right, so this is asking for the determinant. And how do we find this? We find it by doing A11 times A minus, always minus, A12 times A21. Now, every year I talk about this in a different way because people say, well, how am I going to remember that? What I talk about is this. We do the fish. All right, it looks like a fish swimming to the right, not to the left. And you have A11 times A22 minus, and if you want to, you can even give the fish a little mouth for the minus. A11, A22 minus A12 times A21. All right. So I made them kind of look like an unhappy fish, but you can use this for every 2 by 2 matrix. So what is that going to look like? Let's take a look at an example. Excuse me. All right, so for example, if I gave you this problem where I said this, all right, that is, again, this is asking for the determinant because of these brackets on each side, the bars, right, rather than brackets. So this is equal to -2 times 7 minus 4. Whoa, it does not want to let me write. 4 times 3. Whoa, all right. What's going on? Okay. 4 times 3. So this would be equal to -14 minus 12. And that would be a -26. This is the determinant of that 2 by 2 matrix. All right. Let's take a look at how we can use this. All right. Well, let's just do one more first. Let's do another one. I'm going to give you one, and I'm going to tell you to pause and try to do it yourself. All right. So let's do 3, -1, 5, 6. All right. So pause the recording right now and go ahead and try to solve that. All right. I'm going to assume you're back. All right. We're going to look at it. And that would be 3 times 6 minus -1 times 5. So that's 18 minus a -5, or 23. This would be the number associated with it. So that's how we do a 2 by 2 matrix. And you say, well, why do we need a video for just that? Because it doesn't stop at 2 by 2. We're going to go on 3 matrices. Now, with a 3 by 3 matrix, it would look like this. All right, we've got 3 by 3 would be A11, A12, A13, and then it would be A21, A22, A23, A31, A32, and A33. Now this is our matrix A, of course, and it's a 3 by 3 or a third order matrix. And the way we do this, and I'm going to use color to try to demonstrate how we do this. The way we do this is we look at this first row, and we start by looking at this value. That's the first value we're going to write down, is A11. And when we write that down, we're going to eliminate the row and the column that it's in and just focus in on these 4 that are left. And we're going to look at the determinant of that little group, so that we have this determinant times that first value in the first column, first row. All right, so we have that. And this will be a number. We'll have a number times what this determinant comes out as a number, and that'll give us that value. Now, that's not where we stop. That's only the beginning. Next, we go to this number in the first row. We're going to use the first row for this whole thing. Now, technically, you can use all the rows, but we'll get into that later, maybe. So for A12, now this first one we did whatever that number was. It's the positive version of it. Here, we're going to always use minus. So if A12 is a negative, it would be minus a negative, and that would be a positive, but it's just minus normally. It would be plus, minus, and then we're going to go back to plus in the next one. And yes, there is a next one. So we would have A12, first row, second column, times the determinant when we get rid of that same row and the column it's in. So it leaves us these 2 and these 2. So we'd have A21, A23, and then A31 and A33. Okay, so in the second position, we're using this, and you have 1s and 3s for your columns. You had 2s and 3s for your columns here. So finally, if you're seeing the pattern, you probably know what's next. We're going to look at A13. Now this is going to be plus all the time. Again, if it's plus and negative, then it becomes negative, but it's plus A13. And again, if you see the pattern, we're getting rid of this and this, leaving us the first and second in that second row and second and third row. So A21, A22, and A31, A32. And again, we would find all these numbers. Now, this is just the conceptual model. That when you see it with numbers, I think it becomes a little easier. Not drastically easier, but a little bit easier. All right. So let's take a look at that. Let's do an example and see how that works. Excuse me. All right. So let's go back to black here, and let's look at a problem. let's do this one. -2, 4, -1, 4, -3, 2, and -1, 5, 4. All right, so we have this going on. Oh, why is that not going away? There we go. All right, so where am I going to start? Well, I have to start with this one here, -2 times the determinant created by getting rid of this row, this column. So it'd be -3, 2, 5. And then we do minus, always minus for the second one, just like you see up here. Bring it down a little bit. And now we're going to use this number. So we use 4 times. Now we're going to get rid of this column, and we have these two left. So it would be 4, 2, -1, 4, and then plus this here, -1 times determinant when we get rid of this column, this row. So 4, -3, and -1, 5. And we've got our setup. Now we have to find the numbers. So let's do this. Now we're going to do what we did for all those second order ones. We're going to do -3 times 4, that's -12, minus 2 times 5, that's 10. Then minus 4 times 4 is 16, minus 2 times -1 is a -2, plus -1 times 4 times 5 is 20, minus -3 times 1 is -3, or +3, sorry. So -3. And we can then look at -2 times -22, minus 4 times 18, plus -1 times 17. So this would be 44. Let's see, this is 72, I believe. And this I'll call it, it's plus the -17, so I'm just going to call it -17. And when we get done with that, what do we have? We've got 44 minus 89. So I believe that's a -45, right? Yeah. So that is the determinant of this 3x3 matrix. All right. Again, that's how we do. Now, well, we did 2x2, 3x3. Now notice 2x2 was the base idea of how to find a determinant. With 3x3, we just broke it down into 2x2s. So what do you think is going to happen when we get to a 4x4? And let's just do an example. Let's do 3, 1, 2, or -2, 4. And then -1, 0, 5, 6, -3, 2, -1, 4, and 6, 1, 0, 3. All right. So what are we going to do for this one? I'm going to go down to work on this beneath it because I need the room. We're going to start the same way. We're going to do the 3. And it's going to be times the determinant that we get from eliminating row and column. So we get 0, 5, 6, 2, -1, 4, 1, 0, 3. Then minus, just like before, use the 1. And that is going to be times, get rid of that row and column. So I'd have -1, 5, 6, -3, -1, 4, and 6, let's see, 0, 3. Then we do plus. We use the next one up here. Get rid of that row and column. So we're using these two in that one. So it's -2 times. All right, -2, then it would be -106. And then -3, 2, 4. Then 6, 1, 3. and then minus again. And the last one is 4 times this determinant, which again, getting rid of this row and column would be negative 1, 0, 5, negative 3, 2, negative 1, and then 6, 1, 0. So now we would go through and do each one of these. So I'm just going to look at this one right now. To do this one, I would have this is equal to 3, and it's going to be times all these things. So I'm going to do the same thing I would do for the others. I'm going to look at this and say I would have 0 times the determinant that we would have from getting rid of this row and this column, which would be negative 1, 4, 0, 3, minus 5 times, and I get rid of that row and column, 2, 4, 1, 3, and then plus 6 times this one, which would be 2, negative 1, 1, 0. And so we'd have all of that. So now this is just for the first one. Now keep in mind, all we're doing is that one that's outlined here in green. We still have these other 3 to do. So what we did is we took a 4x4, broke it down into 3x3s, which we then have to break down into 2x2s. So this takes a little bit of space if you're going to write everything down. So I have 3 times, well, this is 0. I don't need to worry about it. 0 times whatever this number is, so it's 0. Minus 5 times 6 minus 4 plus 6 times 0 minus a negative 1. And so we would have this equal to, let's see, well, let's do that over there. Let's keep the pattern going. We'll do this equal to 3 times, that's going to be negative 5 times 2, so that's negative 10. And then this is 6 times 1, so that's plus 6. So this would equal negative 10 plus 6 is negative 4. 3 times negative 4 is negative 12. So we found the number for this determinant up here. This would be negative 12. Now we would have to go and do this one, and then this one, and then this one. Find all those numbers and combine them. All right, so we would have this number minus whatever this number is, plus whatever this number comes out to be, minus whatever this number comes out to be. I'm not going to take up your time by going through all that calculation, but I will tell you it takes time. You've got to do what I just did here for each one of these other 3. Now, are we going to give you a 4x4 on a quiz? Probably not. You might see one in homework, and this can keep going, guys. By the way, you can do a 5x5, and we have given like a 5x5 or a 6x6 as like extra credit some years, and you may see that show up. But think of what you have to do. If we go to a 4x4 and it brings it down to 3x3s, if I go to a 5x5, then it brings it down to 4x4s that you have to bring down to 3x3s and bring down to 2x2s and so on. This always comes back to the one we can find by hand is the 2x2. All right, so this is what we can do. And that is how you find the determinant of any nth order matrix. All right, you're going to have some practice on this in the textbook, and we'll go over questions tomorrow. Have a wonderful day, folks. I will see you tomorrow.